This is Pre-Calc section 6.5 on determinants and Cramer's rule. This is the first of probably 3 videos that it will take to cover the material in this section. The determinant of a 2 by 2 matrix is defined this way. If A is this matrix containing elements A, B, C, D, then the determinant of A is a real number defined like this. It is an arithmetic process. It is multiplied down the main diagonal, A times D, minus coming back up the other diagonal. So it's what I call the downs minus the ups. And that's all you have to do to get the determinant. It is defined that way. Now, I don't use the same notation as the book. I think it's just easier to use these letters like this. So all we have to do to get the determinant of these 2 by 2 matrices is to multiply down the diagonal. Negative 3 times 9 is negative 27, minus, always minus because that's what the formula says, come back up with a product. 1 times 4 is 4. Negative 27 minus 4 is negative 31. You'll see in a little bit what we use determinants for. Starting in the upper left-hand corner, multiply down. 2 times 4 is 8, minus, multiply coming up. 1 times negative 3 is negative 3. Minus and minus is plus, gives me 11. 6 times 2 is 12, minus, multiply coming up, 12. 12 minus 12 is 0. So it's entirely possible that the determinant equals 0, and that will mean something for us in certain problems. To use the diagonal method, you will, number 1, rewrite the first 2 columns to the right of the matrix. So 2, 1, negative 1, 3, 8, negative 2. Secondly, you find the products of the elements of what I call the down diagonals. Now, I'm starting in this upper left-hand corner. Think how you read a book. You start in the upper left-hand corner of the page. So find the products of the elements of the down diagonals. That's one down diagonal. 2 times 8 times 3 is 48. Plus the next down diagonal. 3 times 1 times negative 1 is negative 3. Plus 1 times negative 2, which is negative 2. And that's all the down diagonals that we have. You might look over here at this 1, negative 2, but it's already included in that down diagonal. So it's 3 down diagonals using the numbers in the top row as your beginning of your down diagonal. And there are plus signs in between each of those numbers. Minus, because at the bottom it says subtract the ups from the downs, minus the ups. So starting in your lower left-hand corner, this set of diagonals. Negative 1 times 8 times 1 is negative 8. Negative 2 times 1 times 2 gives you negative 4. And 3 times 1 times 3 gives you 9. Then complete your arithmetic. 48 minus 3 minus 2 is 43. Minus, inside here, negative 8 minus 4 is negative 12, plus 9 is negative 3. So minus and minus is going to give us a positive. So what we've done here is we've used all of these numbers in this matrix. You might look and say, wait, we didn't use that 8, but we did. It's right there. And you might think about not using that 1, but we did right there. That's why we wrote those 2 columns outside. So it is all of the down diagonals, that's the blue, minus all of the up diagonals, that's the black, and then do your arithmetic. So the diagonal method is a pretty easy method. Let's do another one like this. So let's write our 2 columns on the outside, and be very careful when you do that you copy correctly. It's very easy to leave a sign off somewhere. So down diagonals, 1 times 3 times 2 is 6, plus 5 times 2 times 5, 50, plus 3 times negative 2 times negative 1 is 6, minus parentheses, and then go do your up diagonals. 5 times 3 times 3, 45, plus negative 1 times 2 times 1 is negative 2, plus 2 times negative 2 times 5 makes negative 20. Clean up your arithmetic on the outside. 6 plus 50 plus 6 will be 62, minus parentheses. the blue inside there. 45 minus 2 minus 20 will be 23, and 62 minus 23 is 39. You see this plus and negative 2. If you'd rather write 45 minus 2, that's just fine. I'm just trying to emphasize that between each of the products, there is a plus sign. The only place you have a minus here is between all of your down diagonals minus your up diagonals. So it's the downs minus the ups. One more. Let's write these two columns outside. 5, negative 5, 1, negative 3, 3, 0. Down diagonal starting in the upper left-hand corner. 5 times 3 times 1 is 15, plus negative 3 times negative 2 times 1 is 6, plus 2 times negative 5 times 0 is 0, minus parentheses. Let's work our way up. 1 times 3 times 2 is 6, plus 0 times negative 2 times 5 is 0, plus 1 times negative 5 times negative 3 is a positive 15. Outside is 21 minus 21, which is 0. As we saw in the 2 by 2 example, it's entirely possible that the determinant equals 0. Now we're going to evaluate the determinant using a method called expansion by minors. It's a little more complicated than the diagonal method, but the reason we have to learn this is that the diagonal method only works on a 3 by 3. Expansion by minors will work on any size, 4 by 4, 5 by 5, etc. Also, there's some terminology and steps in here that we will use when we do the inverse of a matrix in another section. So it says, number 1, write out what's called the sign matrix. And the signs for these positions alternate, starting in the upper left-hand corner with a plus. So it's plus, minus, plus, etc. What's just as easy to look at rather than writing out the whole sign matrix is that your negative signs are in these positions. Now, I should also say I teach this a little differently than the book. So my way is to lay out these signs like this. You have negative signs in those 4 positions. Now, you're going to expand using any row or column. And if there's a 0 somewhere, you'd like to use that 0 or column. I'll show you one of those in a couple of minutes. So I'm going to expand on the first row just because it's the first row. So you're going to write out the row or column number. Since I'm going to do it on the first row, I'm writing out 2, 3, 1, spreading it out a little bit, and going back and picking up any negative sign I might need. There's a negative sign in this middle position, so this 3 gets a negative. That means the 1 will get a plus, and of course the 2 being in the very front doesn't get any sign in front of it at all. So far all we've done is choose the row, write out those coefficients, and get the appropriate signs based on this. I just think about the negative signs being in that diamond configuration. Now you want to put next to each of those numbers a little empty 2 by 2 matrix. This little empty 2 by 2 matrix next to each one. We're going to fill into those empty 2 by 2 matrices by doing this. It's called strike the row and column for each number in the row or column that we chose. Well, that sounds kind of complicated, but what I do is this. Since we are expanding by the top row, I'm just covering up the top row. I don't need it anymore. And I'm going to let this cover bounce from here to here to here. Go back to this one. Do you see a little 2 by 2 matrix sitting there? Sure. And it is 8, 1, negative 2, 3. Be sure when you do this step that you are copying correctly. If you do one silly little thing like drop off that negative, everything will be wrong. Now I want to let that slide over here. Do you see that little 2 by 2 matrix? So that matrix is 1, 1, negative 1, 3. And then I will let this slide over one more. And I've got 1, 8, negative 1, negative 2. And before you go on, always double check that you've got the signs there, 1, 8, negative 1, negative 2. So we've done the hard part. What's left now is just arithmetic. We want to find the determinant of each 2 by 2 matrix and multiply it by the coefficient in front. So this will be 2 times. Getting the determinant of a little 2 by 2 is very simple. 24 minus negative 2. And minus 3. This is 1 times 3 is 3. Minus negative 1 plus 1. I don't really need to write it, but I'm just being consistent here. 1 times negative 2 is negative 2 minus negative 8. And just clean up the arithmetic there. 24 minus a minus is plus. So this is 2 times 26, which is 52. Inside here, minus a minus is plus. So this is minus 3 times 4, but this is minus 12. And negative 2 minus a minus, this goes to plus. Negative 2 plus 8 is 6. 1 times 6 is a positive 6. And this will give us 46 as the determinant of that 3 by 3. And this matrix may look familiar to you because it is one that we started with when we did the diagonal method. So that's the same answer we got for the determinant doing the diagonal method. It is an involved process, but if we have a matrix that's got some zeros strategically placed, then the arithmetic becomes a whole lot easier. Also, some terms that you'll need for Math Lab. Notice this was called expansion by minors. What a minor is? The minor is the determinant of any particular 2 by 2 matrix. So this little 2 by 2 matrix, the determinant was 26. So the minor that is associated with that number, that 2, is 26. The cofactor, that's a word we'll need in another section. The cofactor is the product of the sign times the determinant of the 2 by 2 matrix. So for 3, which is sitting right here, and went with that matrix, the minor for 3 was 4, because that was the value of the determinant, but the cofactor is negative 4 because it was sitting in a negative position. Let's look at an example here where we expand by the first column, only so that you see how it works with the column. The process will be the same. There's the column I'm going to use. Remember to look at your sign configuration. Those are the only positions that have a negative sign. And remember, we're talking about the first column. So there is a negative sign that goes in that middle position. So when I write out these numbers, I'm writing them out as is. 1, negative 2, 5. Then I go and think about what the signs say. This is a positive position, so that says leave that sign alone. This is a negative position, and that says change that sign. That was a negative. It needs to change to positive. That is a positive position. That says leave it alone, so it's a positive 5. So we've got our coefficients written out. We've also got the signs written out with them. Draw your little blank 2 by 2s. Time, because I'm expanding on the first column, I'm covering up the entire first column. And this cover will bounce from here to here to here. So when I cover this up, what I see is the 2 by 2 matrix, 3, 2, negative 1, 2. Go down 1. Those entries make up this 2 by 2, 5, 3, negative 1, 2. And take the cover and bounce it down 1 more. Gives me 5, 3, 3, 2. So that's the hard part, getting everything set up where it goes with the appropriate signs. Now it is just arithmetic. This is 1 times this determinant, which is 6 minus negative 2. This one is 2 times 10 minus negative 3. And this is 10 minus 9. So clean that up. Minus and minus is plus. 1 times 8 gives me 8. Minus and minus is plus, so that's 13 inside there, times 2 is 26. Here, 10 minus 9 is 1, times 5 is 5, and that gives us 39, which is the same answer we got for the determinant of this matrix using the diagonal method. All right, this one's got a 0. It's lovely if you can get 2 zeros, but we only have 1 0. So the 1 0 is right there. You have a choice. You can go by the middle column, or you can go by the bottom row. Well, the other thing I like about the bottom row is that there's 1s there, so I won't make some silly distributive mistake with my multiplying. So that's the row I've chosen. Those are the numbers I'm going to write out. I'm going to look at my sign configuration. So this right here is a negative position, which doesn't matter. I put a negative in front of 0. That's going to totally go away anyway. So I've got to put my matrix here. I can go ahead and put the matrix here. It doesn't really matter what it is, because 0 times anything is 0. That 1 is a positive 1, so I need to put a plus there. And then it's time to grab the covers and move them around. So I'm covering up the bottom row because that's the row I've chosen to expand on. Slide this over, and you see a 2 by 2 matrix there, which is -3, 2, 3, -2. Since you're expanding by the bottom row, that's the cover that stays put. We need to slide this one over, and you see 5, 2, -5, -2. Not that it matters because all of that's going away. I didn't even have to fill that in. And then this over here will be 5, -3, -5, 3. Do the arithmetic. This is 1 times, so I didn't even have to write that 1. -3 times -2 is 6. -6, that's 0. Same thing here. This is a 1. Don't even need to write it. 15 minus 15 is 0. So 0 plus 0 has a determinant value of 0, which is what we got using the other method.